Now, this is another interesting concept, and we have seen this when we're talking about filtering. So padding is try to add like extra values in the borders so that you are able to place your filter at all the locations in your input image. Okay, usually like there are many different variations. I think we discussed those in the first or second lecture when you're talking about filtering. Usually zero padding is used. So by zero padding, we mean you just use a value of 0 in the border. Okay, so then if you're using a 3x3 filter, you can see that if you have these 0 values, you will still be able to place your filter at the first pixel location. Earlier, it was not possible. So that's one motivation to use padding. The other motivation is if you want to control like the shape of the volume as you move from layer to layer, then again padding is very useful. And in most of the cases, if you want to preserve the shape of your volume, then padding plays a very important role. Okay, so in this case, if your feature map was 7x7, you're going to use a 3x3 filter. You can just use padding of 1. And your updated formula will become something like this, right? And this equation is actually taking into account padding. So you can keep a note of this. I think later we will have a pop quiz based on this. In this case, N is your size of the input activation map. F is the size of filter. P corresponds to padding, like how many values you're going to add. S is the stride. So one thing you can observe here is these are just numbers, but in reality, like if you're working in two-dimensional space, your kernels will be 3x3, your input feature map will be 7x7. And in that case, again, your padding is, again, it's not going to be 1, it will be 1x1. And each axis represents padding in the corresponding dimensions. Again, your stride is 1x1, it's not 1. But when we are using this formula, we are just considering one of the dimensions. And we're assuming that like it's symmetrical. So we just have to do it once. But it may happen that if your input size is 7x9, then you will have to compute the values separately for 7 and separately for 9. And similarly, you can have odd shaped filters as well. Let's say 3x5. So we'll compute like these values independently for each dimension here as well. Okay, so usually we will see like a padding of a stride of 1 where we are not skipping anything. Okay, so then the idea is if you want to figure out like what kind of padding you have to use so that you want to preserve the shape, then you can again make use of this formula. Because if you want to preserve the shape of the volume, then the output should be n, which is again the shape of the input. And then you can just solve this equation. You will have n, you will have f, right? You will have s. You just need to find the value of p. So this is just like with basic mathematics, and p is equals to this f minus 1 over 2. So depending on the size of the filter, you can figure out how much padding is required for this kind of activation map if you want to preserve the volume.